Well, thank you, Ken. My name is David Dustin, and my company is Dustin Productions. We create forensic animations. Basically, the topics I'd like to cover are, what I think are just some very fundamental things that accident reconstructionists should consider as they're as we all move into the realm of 3D scanning. It's coming, whether you're ready for it or not. I was hoping it wasn't coming as soon as it was, but it is, and so we have purchased a laser scanner as well. Basically, quickly, who we are, what we do, how this applies to accident reconstruction, and I don't want to bore you with a lot of details. We create photorealistic animations, which is really our driving force. We try to make things look as realistic as possible. 90% of what we do is vehicular in nature. About 10% at this point is criminal, but that percentage is growing all the time. We work with reconstructionists from all over the country. We're not prejudicial. We'll even work with people outside of Georgia. So we build our scenes from conventional site surveys for the most part, and we're starting to use 3D laser scans as they've come in, and we've also contracted with people to make scans for us, and as we wait for our laser to arrive. We create a graphical representation of the expert's opinion. In other words, if the reconstructionist says this truck flew 22 feet in the air, then by God, that's what it does. We are not reconstructionists. We need you to provide us with the data that we need. I'd like to comment on conventional surveys versus 3D laser scans. Most conventional surveys that we get consist of anywhere from 150 to 250 data points, and you all know the acronyms that get used: edge of pavement, fog line, yellow line, white line, point of impact, guardrail. You all know how that works. Laser scan, conversely, consists of about anywhere from 500 million to 800 million data points, although Ken said we can go over 1 billion. I guess that's not too much farther than what we're talking about. And of course, they don't have to be that high resolution. It just helps to have any extra data that you may need. From our perspective, constructing a 3D environment from a conventional survey sometimes requires us to estimate feature location, elevation changes, and this is one example. This particular case would have been very handy to have a 3D laser scan of this road edge right here. As it was captured with a conventional survey, and so even though you take a number of cross sections and do many measurements, it still would pale in comparison to be able to do a 3D laser scan of that edge. In this particular case, this truck had dropped off the edge of the pavement, and then the suspension had buckled and thrust the vehicle into the air. Constructing an environment from a 3D laser scan obviously allows us to place content and everything much more accurately. Adding important features that are missed in the initial site survey can be problematic. For instance, you're meeting with your client, and your client says, "Well, this object is located in these images. Why isn't it in the scan?" Or someone will say, "Well, there's a sign here. How tall is the sign?" And it wasn't captured in the site survey. So whereas if it's done with a 3D laser scan, you can go back and you can say, you can just identify the object or whatever, locate it, and create a model to occupy that same space. And I think the biggest area this would have an effect on would be in line of sight cases. You know how difficult it is to quantify how large a bush is or how large a tree is. We had a case where line of sight was definitely an issue, And I don't have that one open. Anyway, where line of sight was an issue, and so we used the placement that the accident reconstructionist had given us, but basically it was just the major diameter of the tree's base. And so we had to, through photographs, place a tree that was the same basic construction or same basic proportions. Critiquing the opposition's site survey and their subsequent drawings can be very difficult to do and to substantiate, whereas with a 3D laser scan, if the opposition says that the road lines are in this configuration, you can very easily go back with the scan and say, no, you know, the lines are located over here or whatever. Most times, and I'll equate this to here in Georgia on Interstate 75 through Atlanta. Conventional site survey, we did a case where, let's see if I have that one loaded. This was across Highway 75, so there were 7 or 8 lanes that we had to try to do a site survey on, and we even did it on a Sunday morning, and it was very difficult to get the centers of lanes, even though they're supposed to be standard and all of that. But, you know, for instance, this is an overpass, and getting all of the lines in the overpass to line up correctly, the placement and heights of the signs. So it was difficult at best to try to get an accurate topography of this highway. We were able to get the outside edge and a few points in between, but the traffic was just too heavy. Whereas with a 3D laser scan, you'll get everything from the road reflectors to what we call road gators. I don't know what the rest of you call them, but these are the tire carcasses from tractor trailers. Everything will be in the scan. Sometimes you'll even get birds in the scan. There'll be traffic as vehicles pass through the environment. You'll get basically a slice of a vehicle as it goes through, but you can clean that up later. It's still much safer, and the data has much more integrity. Vehicle crush measurements, Ken already talked about that pretty extensively. But one thing I wanted to make sure that if you get a scanner and you do a scan of a vehicle, make sure that you coat any reflective surfaces, such as glass or chrome bumpers, or even if the vehicle's finish itself is quite reflective. What you'll find is it'll generate noise in your scan that you'll have to try to eliminate later. It's much better to use a little bit of prevention. Inspections. We all know that when you as reconstructionists go on a vehicle inspection, you have probably the opposing reconstructionist, probably 4 or 5 lawyers standing around. Everybody's watching, and you have to make sure that you get all the information you can possibly think of. Well, you can still do that, and if you do a laser scan and you need to go back and you need to say, somebody says, well, this bracket was bent during inspection, and you have a scan where you can go back and you can look at it, and you can do it from your desk.